analyzing and interpreting graphs. It means we're going to read the graph and understand what it's trying to tell us. And most often we use that to answer questions that we're being asked about the graph. So here I have a line plot about the number of recycling containers collected. I see here on my x-axis that those containers range from 20 to 50, and that these numbers are representing the total collected per, so for every one student. First question I'm being asked says, how many students were surveyed? Well, you remember that the X on a line plot represents someone's answer. So all I have to do here is count the X's to see how many people were surveyed. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students were surveyed. Question number 2 asks us, how many students collected more than 35 containers of recycled materials? Well, the keywords here are more than 35. So 35 is not more than 35, so I'm only looking at the ones that are past that. Since line plots organize data from least to greatest, all I have to do is look past 35 and see that 1, 2, 3, 4 containers were collected, or 4 students, collected more than 35 containers. I'm going to continue to read the graphs here. This time we have a circle graph or pie chart about class president. First question says, who was voted class president? Well, you remember that each wedge is showing how much that particular student got out of all of the votes. And so since Billy has the biggest wedge or the biggest piece, then Billy was voted class president. What part of the votes did Susie get? And it also asks us about Roy. Well, if Billy got half, then that means that these two were half together. But if I'm looking for Susie by herself, then I would want to imagine pieces filling this whole circle that were the same size as Susie's. So this line going here, I could recreate it here, and then that would leave me one more about the same size. So I see that Susie's is about 1/3 of the votes, and then Roy is about half of hers, so he would be 1/6 of the votes. And so if I know that 90 students voted, well, if Billy won, he got half of the 90, which would be 45. Susie got 1/3. Well, if we divide 90 by 3, that would be 30 votes for Susie. And then Roy got half of Susie, so he got 15 votes for class president. So by comparing the size of the wedge to the total represented by this entire circle, I can determine how many votes each person got. Next we have our line graph showing us some temperature readings. These temperatures were taken during different times during the same day. And the first question is asking us about the trend. Remember that the trend describes the general pattern of this line. And so the trend would be that the temperature is rising as this day goes on. Next question asks us, between what 2 hours did the temperature change the most? Well, the line that's connecting the temperature from 6 a.m. to 7 a.m. is a good indication of how much change is happening. And so when I look at the slope of this line, it's not very steep, if you will, but as I'm moving along the line here on the graph, I see that the line gets really steep right here going from 8 to 9 a.m. on this particular day. It gets steep again here from 10 to 11 a.m. And so I'm looking for the change that happened the most. It's obviously not going to be between 1 and 2 p.m. because that line is almost straight across. So after I identify the steeper parts of the line, then I can go back, read more carefully the temperatures here of this graph. At 8 a.m. it was 40 degrees. At 9 a.m. I'm going to say it was about 48 degrees, so that would be a change of 8 degrees. Over here at 10 a.m. it looks like it was about 51 degrees, and right here at 11 it would be about 57 degrees, so 51 degrees to 57, 57 minus 51 would be 6 degrees, and so this is close, but the temperature change between 8 and 9 a.m. was the greatest. biggest or the largest change? Favorite colors. I hope you can see my yellow here. I don't know how well that's going to show up. But you see that these are the colors, and over here on my y-axis this time is telling me the number of students that liked this color the best. So bar graphs, you remember, are good for comparing quickly. It says what was the favorite color. That's my tallest bar. Definitely blue was the favorite color. What about the least favorite? Again, looking now for the smallest, I see green. And then question number 2 says how many students were surveyed. So now I'm going to follow this bar up to the y-axis and see exactly how tall it is. I read there were 8 students. Yellow is between 2 and 4, so that's going to be 3 students. Blue, following that over to my y-axis, 14 students. Green was just 1. Pink and purple, they were the same, and they are both 4 students each. And so if I want to know how many students were surveyed in all, I'm going to add each of those numbers together, which I did right here, and you see that that totals 34 students were surveyed for about their favorite color. In your math journal, I want you to look back at the graphs. We have them in our math journal printed there on your page, and you can also rewind the video if you want to see the graph itself. And we're going to answer these questions in your math journal, please.